Pre-statistics. Using function notation with linear models, Part 3. Lesson objective. Find the domain and range of a model. Lesson objective. Example 6. A store is open from 9 a.m. to 5 p.m. Mondays through Saturdays. Let I equal f of t be the employee's weekly income in dollars from working t hours each week at $10 per hour. Number 1, find an equation of the model f. Number 2, find the domain and range of the model f. Solution: the employee's weekly income measured in dollars is equal to the pay per hour times the number of hours worked per week. So f of t equals 10 times t. Number 2, to find the domain and range of model f, we consider the input-output pairs only when both the input and the output make sense in the situation. So time is the input. Since the store is open 8 hours a day, 6 days a week, the employee can work up to 8 times 6 or 48 hours each week. So the domain is the set of numbers between 0 and 48 inclusive. So we would say function notation 0 less than or equal to t, which is less than or equal to 48. So this means t can be any number from 0 to 48, and it can equal 0 and it can equal 48. Income is the output. Since the number of hours worked is between 0 and 48 inclusive, the pay is $10 per hour. The range is a set of numbers between. So we're going to take our domain and write the range. So since we have $10 per hour, the domain tells us the number of hours that are possible. So this is going to be 0 times $10, which is $0, and 48 times $10, which is $480. So the range is from $0 to $480 inclusive. The figure represents the inputs 24, 36, and 48 being sent to the outputs 240, 360, and 480 respectively. So here's the inputs, members of the domain, and the function produces the outputs. And this would be the members of the range. This would be the income. So we go from t, then f changes it to I. We also label part of the t-axis that represents the domain and the part of the I-axis that represents the range. So the domain is the number of hours, 0 to 48, and the range is from $0 to $480. Notice there's an endpoint here for this graph. This is where it stops. We always find the domain first, then we find the range that comes from this domain. The domain of a function is not always specified explicitly. If no domain is specified for the function f, we take the domain to be the largest set of numbers x for which f of x makes sense. The domain and range of functions that are embedded in real-life applications are always restricted to values that make sense. Let's do an example. Tuition costs, TSC, calculated in dollars for part-time students at a nearby college is given by TSC equals 150 plus 200 times C, where C represents the number of credits taken. Number 1. What is the independent variable? What is a reasonable domain for this function? Use proper math notation. Number 2. What is the dependent variable? What is the resulting range for your domain from part 1? So let's do one first. The independent variable is the number of credits taken. A reasonable domain for this function would have to be a value larger than 0, because if you're taking 0 credit hours, you're not going to be considered a student. but at the same time it has to be less than 12, because at 12 credit hours you're considered full-time, and here we are wanting part-time students. So the reasonable domain would be the number of credits C that would be greater than or equal to 1, and at the same time less than or equal to 11. So all discrete numbers between 1 and 11 inclusive. Number 2, the dependent variable is the tuition cost. The resulting range comes from this domain. So we take 1, we put it into the function. We take 11, put it into the function, and we see that the resulting range, the tuition costs, are less than or equal to $350 and up to and equal $2,350. Let's do another example. You read in the newspaper that a local river is currently polluted with 285 parts per million of a toxic substance, and that the local environmental officials estimate they can reduce the pollution by 15 parts per million per year. The equation to model the amount of pollution A and the river after n years is as follows. A of n equals 285 minus 15n. Number 1, explain why this relationship is a function. Number 2, what is the independent variable? What is a reasonable domain for this equation? Number 3, what is the dependent variable? What is the resulting range from this above domain? Number 1, for each year there is one and only one value for the amount of pollution. So this is why this is a function. For each year there is one and only one value for how much pollution is in the river. Number 2, the independent variable is the number of years. A reasonable domain would be, since we're talking about the amount of pollution when n is 0, the largest amount of pollution is 285. The smallest amount of pollution is when the pollution amount is 0. That happens when n is 19. So a reasonable domain would be from 0 to 19 inclusive. The dependent variable is the amount of pollution, and the resulting range from the above domain would be the pollution would be between 0 and 285 inclusive. Thanks for watching.